Aldehydes will be named with the suffix "al". The parent chain must contain the carbonyl functional group, and generally, unless there's a higher priority functional group in naming, the carbonyl will typically be carbon 1. Here's a few examples to illustrate these rules. The first example is heptanal. It has 7 carbons. The carbonyl is, of course, at the beginning of a chain, since an aldehyde, by definition, will be always on the edge of a molecule. So the carbon that contains the aldehyde will be carbon 1, and then we're going to number from right to left. On the next example on the right, we have a 5-carbon aldehyde. So this would be named as pend. It has also an alkene on carbon 2, so 2-ene. And then we have the suffix "al" to indicate that we have an aldehyde. Notice that we don't number generally the location of the aldehyde. You could, it wouldn't be wrong, but we don't need to, since the aldehyde is by definition at the beginning of a chain. It is always going to be carbon 1. We also have a methyl substituent on carbon 3, so we add 3-methyl in front of the name. And then lastly, we look for any stereochemistry. In this case, we have a double bond that has E stereochemistry. You can tell that by the fact that the aldehyde is going in this direction, and then between the methyl and the ethyl group, the ethyl has a higher priority, and that one is going in the opposite direction as the aldehyde was. So therefore, we name this or give this E stereochemistry. In the last example here, we have a 6-carbon aldehyde. So this would be named as a hexanal. Once again, we don't really say where the location is, since the aldehyde is assumed to be on carbon 1. We do have 2 substituents, a methyl group on carbon 4 and a hydroxy group on carbon 5. So we alphabetize those 2 substituents. So it's 5-hydroxy, 4-methyl. Lastly, we look for stereochemistry around carbon 5. There is R stereochemistry. So oxygen is highest priority. This chain is second priority, and the methyl group is the last priority. So going in a clockwise fashion, we are going to we're going to have R stereochemistry. And then on carbon 4, we have a methyl substituent that has stereochemistry as well, which is also R. In this case, this carbon here, carbon labeled as 5, is the highest priority. Carbon 3 is the second highest, and the methyl is the third highest. So we would go from 5 to 3, again going on a clockwise direction, and therefore this is R. Like many functional groups, aldehydes are sometimes named through their common names. For example, formaldehyde has a single carbon. It is the simplest aldehyde we have. Acetaldehyde has a methyl group along with the aldehyde, and then benzaldehyde has a benzene ring next to the aldehyde. Note that formaldehyde has been used in preserving biological specimens. So 30% solution of formaldehyde in water is known as formalin, which is an excellent biological preservative. It has been replaced in many cases by other preservatives, such as a 5% solution of ethanol with added antimicrobials. Naming ketones, we want to use the suffix "-one". If we have more than one ketone, we will use the suffix dione, trione if we have 3, and so on. As always, we want to indicate the location of the carbonyl with the lowest possible number. So we would start counting from the side that is closest to the carbonyl. And we have to make sure that the parent chain in naming the compound contains the carbonyl. As an example, we have here on the top left a ketone that has 6 carbons, and if we count from the left, the ketone will be on carbon 3 as opposed to counting from the right where it would be on carbon 4. As a result, we number this as a 3-hexanone, or if we use the newer IUPAC system, hexane 3-one would be the name for this ketone. In the next example, we have both an alkene and a ketone. The ketone, it would be the highest priority group or functional group here. So we would number this from right to left, meaning the ketone will be on carbon 2, the alkene is on carbon 4. So we name this as hex 4-ene-2-one. On the next one, we have 2 ketones, and there are 6 total carbons. So this is named as hexane 2,4-dione. The next example has has 6 carbons, and it has a carbonyl on the second carbon from the right side. So we would name this as hexane 2-one. It has 2 substituents, an amino group on carbon 4 and a nitro group on carbon 5. If we alphabetize those groups, we would have on carbon 4 an amino group, and then 5 nitro hexane 2-one. And then lastly, we add the stereochemistry. The amino group around carbon 4 gives this R stereochemistry. The nitro group on carbon 5 has or gives this carbon S stereochemistry. Notice that the amino group is a new substituent that we haven't covered before. So try to add that to your substituent names. This last example here has a cyclopentanone parent name. So there's 5 carbons in the ring. There's a ketone on carbon 1. So it's named as cyclopentanone. Sometimes we drop this 1 since in a ring, typically you don't need to give the location of the ketones. This is going to be assumed to be on carbon 1. And so we could just have cyclopentanone without the number. We also have a substituent on carbon 3. So if the ketone is carbon 1, the hydroxy group is on carbon 3, going from the top to the right side. And so this would be named as 3-hydroxy cyclopentanone. And then lastly, we have S stereochemistry around carbon 3. So that is added to the name. To remind you, this is S stereochemistry since on carbon 3 there's an oxygen, which is the highest priority group, followed by carbon 2 since it's closest to this carbonyl, and then carbon 4 is the third priority. So we would go from the oxygen, carbon 2, carbon 4. So we're going counterclockwise, which means this is S stereochemistry. If you have an example of a ketone or an aldehyde in a molecule that has another functional group with a higher priority, we can use the substituent name oxo for aldehydes and ketones to indicate that they're on the molecule. In fact, ketones are a lower priority group than aldehydes. So if we have both a ketone and an aldehyde in the same molecule, we can indicate the ketone as a substituent with oxo. In this first example, we have a 6-carbon aldehyde that also has a ketone. So the aldehyde is, of course, on carbon 1. So we would name this as hexanal. And then we have the ketone on carbon 3. So this would be named as 3-oxohexanal. Notice again, we don't need to indicate that the aldehyde is on carbon 1, since by definition, aldehydes will always be on carbon 1. In the next example, we have again an aldehyde and a ketone. And so we would name, and we have also 6 carbons in the parent chain. So this is named as 5-oxohexanal, since the ketone in this case is on carbon 5. We have a substituent on carbon 3. So we add that substituent in the front of the name, so 3-bromo. And then lastly, we have the S stereochemistry of carbon 3. So we can confirm that by looking at the substituents around it. Bromine would be the highest priority group. Then we have this carbon 2, carbon 4. If we start counting or start moving away from the chiral center, we can determine which group has higher priority. So if we move on to the next carbon, we're comparing a carbon to another carbon, carbon 5. And then if we move on to the next set of substituents, we have a double bond to an oxygen. We have a double bond to an oxygen on this side. There's a hydrogen and there's a carbon. So carbon 5 has the highest priority, since as far as determining stereochemistry, because of this methyl group versus this hydrogen on this side. So carbon 4 has the highest priority over carbon 2. So if we go from the bromine to carbon 4 to carbon 2, we're going counterclockwise. So this is S stereochemistry around carbon 3. There's a few common names that you should be familiar with for ketones. Acetone, which is a common organic solvent we're going to use often in organic labs for SN2 reactions, for example, since they're aprotic polar solvents. It is also used for a lot of other industrial uses, like removing paint, among other things. Acetophenone is this ketone here with a methyl group and a phenyl ring. And then benzophenone has 2 benzene rings attached to the carbonyl. This question here asks us to draw the structure of 3-methylbutanol. So I encourage you to try that out before looking at the answer on the next slide. 3-methylbutanol is a very simple aldehyde. Based on the name, you can tell that it is going to have 4 carbons. So but means 4 carbons, and it's going to be an aldehyde. So we want to draw 4 carbons and with an aldehyde on at the beginning or the end, whichever way you want to look at it, of the chain. And then on the third carbon, so if the aldehyde carbon is carbon 1, on the third carbon we are going to add a methyl group to complete the name.